Okay, so we have a quiz on Friday. The quiz is only going to cover 4.3a, b, and c. So it's the parabolas. It's going to be graphing them, finding the vertices, the co-vertices, the foci, or the directrix, the foci, the directrix, and the vertex for the parabola. So you'll be graphing it as well as finding all those pieces, as well as writing equations, given pieces of information. Then you're also going to have to graph ellipses, which is what we're going to do today. The notes today, if you've pulled them in from Canvas, it says chapter 4, sections C and 3C and D. However, the quiz is not covering 4, 3D. It's only 4, 3, A, B, and C. I will teach D tomorrow, but it's not on the quiz. It'll be writing equations for ellipses, which is the easier part of the notes. So today we're going to learn about ellipses, how to find all the pieces of it. Now, at the beginning, when I'm showing you the overview of it, it's a little overwhelming, but when we start to do the examples, it's not so bad. Everybody good? All right, so I will be posting the quiz review with the solutions for anybody who wants to start looking at it, because after I teach today, that's all the information you need for Friday's quiz. So let's go ahead and take a look at what an ellipse is. And it actually looks like an oval. So an ellipse is the set of all points, x, y, in a plane, the sum of whose distances from two distinct points is called a foci, which is going to be constant. And that's going to be our C value. Just like the parabolas, the ellipses also have a foci. The ellipses do not have a directrix. Now, because it's this closed shape, it's going to have a pair of vertices and co-vertices. Now, the plural, this word foci, this is the plural of the word focus. So in the parabola, there was only one focus point, but in the ellipse, we're going to have two. And these foci are always going to be located on the major axis. So we're going to have the longer part of the ellipse, which is the major axis, and then we're going to have the shorter part, which is going to be the minor axis. The endpoints of the major axis are your vertices. The endpoints of the minor axis will be the co-vertices. Now, when we go to set up our equations, we're going to be seeing the standard form when it's horizontal and the vertex, the center, when your center of your ellipse is at the origin at 0, 0, we have two standard forms. We have x squared over a squared plus y squared over b squared, and it's always set equal to 1. This is the standard form when the center is at the origin and when your major axis is the x-axis, when it's horizontal. The way that I can tell which axis is major, the bigger denominator, whatever variable it's under, like in this case, the a squared is always going to be the bigger number, and whatever number it's under, whatever letter it's under, that'll be your major axis. So when a squared is under the x squared, your major axis is horizontal, or the x-axis. And I'm going to always keep my x squared, y squared in the same spot. What I'm going to do is move the b squared and the a squared. So here, when my a squared, or my bigger number, is under the y squared, then my major axis is vertical. It's up and down. Again, your foci will always be on the major axis. The co-vertices are going to be the endpoints of the minor axis. We need to find the values of A, B, and C. The value of A is going to be the distance from the vertex to the center. That'll be my A value. My B value is going to be the distance from the co-vertice to the center. And my C value is going to be the distance from the center to the foci. And we're going to learn how to calculate or find all of these numbers. Okay, A is the distance from the center to the vertex. So A is, I did it in red. So A is the distance from vertex to center. B is going to be the distance from vertex, co-vertice. So from the co-vertices to the center. And then the C value is the distance from the foci to the center. Always remember your A squared is going to be greater than B squared. And the location of the bigger number is going to tell you if your ellipsis is going to be horizontal or vertical. Now, these are the equations only when the center is at 0, 0. Coming up, we're going to see when the center is at a different order pair, and we're going to bring back H and K. So the next slide actually has a summary of what I just said as well. Now, I'm going to actually change this one. I'm going to change this. Now, technically, it could be this way, but I like to keep x squared and y squared in the same spot, and then just change the location of my a squared and b squared. So again, wherever a squared is located, the bigger denominator, that's going to tell you your major axis. So whenever your major axis is horizontal, then this would be the equation you would use. This is your x-axis. And then your vertices are going to be the a value. So it's really going to be plus and minus a, comma 0. The foci would be located on the major axis, and my major is under the x, so plus and minus c, comma 0. And then the co-vertices would be 0, comma, plus and minus b. And they've separated them here for you. We're going to use this, what sort of looks like the Pythagorean theorem, to find the value of either a, b, or c, depending on what we have. So the formula c squared equals a squared minus b squared. We will use that to find either an a squared, a b squared, or a c squared, depending on what's given. Now, when we're filling in and when you're writing the equations, all we really need to find is a squared and b squared, but that's going to be tomorrow. Now, the length of the major axis is always equal to 2 times a. The length of the minor axis is always going to be equal to 2 times b. Now, this is only when the center is at the origin at 0, 0. So let's try some examples. Again, I know it's a lot until you start applying it. And then these are the rules for when it's vertical. Notice that the order of where you place A and 0 are flipped. And then C and 0 as well. So let's try some examples. Now, one other thing that we need to talk about, and we're not going to test you on this. However, on Webassign tonight, they're going to ask you to write in the eccentricity. They're going to ask you to fill this in. And all it is the ratio of C over A. You're going to need to find the values of C and A to answer the questions to begin with. So all you have to do is take that C value and put it over A. Now, if it's, let's say C equal 2 and A equals 3, then you would just put 2 over 3. If one of your values is a radical, let's say that it ended up being 3 over the square root of 2. So let's say your C value was 3 and A was square root 2. You don't need to rationalize it. Webassign will let you enter it just like that. Even if it was the square root of 18 over 5, it's not going to expect you to break it down. So whatever you get for C, whatever you get for B, just put it in just like that. Again, we will not test you on finding E, finding the eccentricity. Again, it's just the ovalness of the ellipse. So let's try an example. So again, our first step is always to make sure that our equation equals 1. So I'm going to divide everything by 64. And now we can see where we're going to be getting these fractions from. Because if you think about it, this first fraction, 4 over 64, this is going to simplify to 1/16. So this becomes x over 16. I don't have to put the assumed 1 here. You can leave it off. And then this one, nothing to simplify, so you just leave it as y squared over 64. And then 64 divided by 64 is 1. Now, notice there's nothing being added or subtracted to the x squared, y squared. So this tells me my center is at 0, 0. There's no h and k yet. Now, again, remember, your larger denominator, that is always your a squared. So my a squared is 64. My b squared is the smaller denominator. It's the 16. I need to find my a and my b value to get my vertices and my covertices. So I need to square root it. So when I square root a squared and 64, I end up getting plus and minus 8. When I square root b squared, plus and minus 4. Always remember, the larger denominator is always your a squared. Now, I need to find the vertices. Remember, the vertices use the a value. And when your major axis, notice my bigger number, is under the y squared. So this tells me that my graph, my major axis here, is the y-axis. So my graph is vertical. So when I go to write in my vertices, I'm going to be putting this a value in the y spot. So my vertices are going to be the order pairs 0, negative 8, 0, positive 8. Now, when it asks you to enter it in Webassign tonight, it's going to ask you to enter the smaller vertice and then the larger. So my smaller vertice is the negative 8. My bigger vertice is the positive 8. Everybody with me on that? So just make sure you're reading how they want you to enter the vertices, the order. Because if you put the 0, 8 first, it's going to mark it wrong because that's the larger one. So just read the order. Okay, the next thing is my covertices. So the covertices are the endpoints of the minor axis. So for my covertices, I'm going to go ahead and put the negative 4, and now it's comma 0. And then positive 4, comma 0. Because the covertices use the b value. So for the vertices, we did 0, plus and minus a. For the covertices, we did plus and minus b, 0. And this is when it's vertical. If it were horizontal, it would be flipped. We still need to find the c value for the focus. So we're going to use that formula. We're going to use the c squared equals a squared minus b squared. So c squared is equal to 64 minus 16. 64 minus 16 is 48. I need to square root both sides, and I end up with C is equal to plus and minus the square root of 48. Now, for the focus point, you need to simplify the radical. But when you're doing the eccentricity, you can leave it unsimplified. So I need to break down 48. So the square root of 48 breaks down into 16 times 3. So it becomes 4 radical 3. So my C value is plus and minus 4 square root 3. Now remember, your foci are always located on the major axis. So for the focus points or the foci, here what I'm going to do is it's going to be 0, comma, plus and minus C. So when I go to enter it, I'm going to do 0, comma, negative 4 root 3 and 0, comma, positive 4 root 3 for your foci. Yes?
How do you find the major axis again?
The major axis is always the bigger denominator. So once I simplified it, notice how the 64 was the bigger denominator and it's under the Y. So whatever letter the bigger number is under, that's your major axis. Does that make sense? And that tells you where to plug in that A value into. So once I found the square root of 64, then I knew my A value was positive and negative 8, and I put it into the Y spot of the order pair. Does that make sense? Okay, so now I've got 7 order pairs. I've got the center, the 2 vertices, the 2 co-vertices, and the 2 foci. I need to now graph this information. So on the quiz on Friday, you're going to find all these 7 pieces of information, and then you're going to put them on your graph. So let me go ahead and come over here and draw my axis. Actually, let's do it in black. Okay, so I'm going to do my vertices in red. So I have vertices at 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I've got a vertice at 0, 8 and 0, negative 8. I also have my center point here at 0, 0. I have my, so this is a vertice. This is a vertice. This is my center. And now I'll do the co-vertices in blue. They're at 1, 2, 3, 4, 1, 2, 3, 4. So they're at positive 4 and negative 4. So a co-vertice here and here. And my foci, let me go ahead and do those in purple instead of black. Do those in purple. Now I'm going to approximate, since you're not using a calculator, the square root of 3. And the square root of 3 is approximately equal to about 1.7. So once I do 4 times 1.7, the foci I'm going to graph, it's going to be negative 6.8 and positive 6.8. So I can go ahead and add that in. One, 2, 3, 4, 5, 6. So about right there. And again, remember, it's always on the major axis. Now, I can go ahead now and connect my red and blue dots. And you want to make it an oval shape. You just don't want to make it straight lines. So when you go to make your ellipse shape, sort of make it kind of curved. It's not straight lines. This is supposed to be like an oval shape. And just do the best you can. And make it an oval shape. I just don't want to see diagonal lines connecting the vertices and the co-vertices. So the purple dots, or the purple points, these are the focus points, or the foci. So we graphed vertices in red, co-vertices in blue, focus points in purple, and then the center was in green. So you need to get all of this onto your graph. Now, when you go to enter the eccentricity, that's the E value, and it equals C over A. Remember, your C value was 4 square root 3, and the A value was 8. I can reduce this to square root of 3 over 2. And that's what you would enter for your eccentricity. You're going to have to enter this. Again, I'm not going to ask you to calculate that or do this on your test or quiz. Let's try the next example. It's already equal to 1 for me. So now I just have to look and see, where is my bigger number? My bigger number is the 9. So this tells me my A squared is the 9. My B squared is the 5. My major axis is the x-axis, because that's where the bigger number is underneath. So now here, what we need to do is, so my graph is going to be horizontal. It's going to be longer from side to side. So now A is equal to the square root of 9, so plus and minus 3. My B is going to be plus and minus the square root of 5. I'm going to leave it in radical form. Let's go ahead and find the C value. So C squared equals A squared minus B squared. A squared is 9. B squared is 5. C squared equals 4. So C equals plus and minus 2. So now let's go ahead and find our vertices and our covertices. Now this time when it's horizontal, remember your vertices. Yes.
Can you show the graph again?
Uh-huh. You know, as far as that foci, where it's the square root of 5, I'm not going to look to say, oh, is it closer to the 2 or to the 3? Just give me the general area of where it needs to be. It needs to be between 2 and 3, which are the 2 perfect squares. Everybody good? All right, let's try with the center not at 0, 0. So here, these are the equations now when the center is not at the origin. We're bringing back our h and our k, just like before with the parabolas, the h and the k was the vertex. Now it's going to be the center of my ellipse. And again, a squared is always the bigger number, and it's going to be under the major axis. So for this one, if you want to memorize this instead as x minus h squared, and then put the a squared here, just remember that h goes with x, y goes with k. So you can also memorize it this way. So, and then again, if the major axis is the x-axis, then once you get the a value, you're adding it to the h of the vertex. Of the center, sorry. You're adding it to the center. If your major axis is y and you want to find the vertice, you're going to add the a value to the k value of the center. And we're going to see this. Let's do some examples. It's easier, I think, when you do examples. But you can use this little reference chart. Now, just like before with the parabolas, when you pull out this center, it's opposite. So this center is going to be the order pair 2, -1, opposite of what you think. Now, you should always check to make sure that your equation equals 1. If it doesn't, we need to fix it. Same thing before. My bigger denominator is my a squared. So a squared equals 16. B squared equals 9. To find C, I'm still going to use this equation. C squared equals a squared minus b squared. So here, a squared if I want to find A, I square root it, plus and minus 4. B, square root it, plus and minus 3. C squared, I'm going to do 16 minus 9. And C squared equals 7. So C is going to be plus and minus the square root of 7. So now I need to find my vertices, my co-vertices, my focus points. So let's go ahead and do that. Now the square root of 7, this is going to be approximately equal to 2.6. I'm just going to round it to the tens place. Now, you can see that your major axis, the bigger number's under the y. So major is going to be y. So I'm going to be adding the a value to the y of the center, which is really the k. So let's do the vertices. So for my vertices, I'm going to be taking my center point. So if you recall from your previous slide, when your major axis is y, what we're doing here is h and then k plus a, and then co-vertices, and actually plus and minus a. And then co-vertices, we would take the order pair, and we're going to do, for the co-vertices, see here, h plus and minus b, comma k. And then for the foci, it's on the major axis, so h comma k plus and minus c. So let's go ahead and plug in the numbers. So for my vertices, h stays the same, it was 2. And then k is negative 1. And then first I'm going to subtract 4. And then I get 2 comma negative 5. And then I also have to do 2 comma negative 1 plus 4. And 2 comma 3. So my two vertices are 2 negative 5 and 2 positive 3. My co-vertices, I'm going to take the h value, which is 2, and then I'm going to subtract the b value, put in my k value, which is negative 1. So this will give me negative 1, negative 1. That's my first co-vertice. And then the second one, I'm going to add the 3. So 5 comma negative 1 is the other co-vertice. And I need to do the same thing for the foci. So again, the h stays the same. And then I take the k, and I'm going to subtract the c value. And then I'm going to also add it. Now, I can't add that radical, so I leave it just like that. Now, again, we approximated the square root of 7 to be 2.6. So when I go to graph this, I'm going to be graphing 2 comma negative 3.6 and 2 comma 1.6. These will be my foci that I'm going to graph. So now I'm going to put in the center, which is this order pair here, the h and the k, and then the 6 order pairs, the 2 vertices, the 2 co-vertices, and the 2 focus points. So let's go ahead and make the graph here. So let's put in the vertices first. So my vertices are at 1, 2, and then 1, 2, 3, 4, 5, 1, 2, 3. So So I've got a vertex here and here. Let me add in the center as well. It's at 2, -1. Then the co-vertices, -1, -1. And then -5, -1. Then I'll add in the 2 foci. So 2 and -3.6, around there. And then 2 and 1.6. Connect the red and the blue. Make your oval shape. And there's your graph of your ellipse. For the eccentricity, remember it's C over A, so square root 7 over 4. Let's try one more example. Okay, last example. Again, make sure it is equal to 1. It's not. Now notice the y minus 3 squared doesn't have a denominator. So I'm going to add a 1 there. Now what I'm doing here to get rid of the 16 or make this equal 1 is dividing everything by 16 or multiplying all these denominators by 16. So then my new equation is x plus 3 squared over 64 plus y minus 3 squared over 16 equals 1. I can see that my major axis or my larger number is under the x squared. So my major axis is the x-axis. I can see that my center point here, I'm going to pull it out as backwards. So my center is at -3, +3. My a squared is the bigger number. It's the 64. My b squared is the smaller one. And to find c, I use c squared equals a squared minus b squared. A squared is 64, b squared is 16, c squared equals 48 again. So this is plus and minus 4 root 3. A value, plus and minus 8. B value, plus and minus 4. So for my co-vertices, my vertices. So since the major axis is the x-axis, we're going to do h plus or minus a, comma k. For the co-vertices, we're doing h, comma, k plus or minus b. And then for the foci, it's on the major axis. So it's going to be h plus or minus c, comma k. If this helps you to write it down like that, you can. So let's go ahead and fill them in. So for the vertices, I'm going to be doing, my center was at, the h was -3. And then I have to do -8, comma, 3. And then -3 plus 8. I'll try to do it next to each other. So then this becomes -11, comma 3 and 5, comma 3. Those are your vertices. Co-vertices. My h value was -3. And then I have to do 3 minus 4, -3, 3 plus 4. So my two co-vertices are -3, -1, and -3, +7. And then my foci, -3, and the C value is going to be minus 4 root 3, comma 3, and -3 plus 4 root 3, comma 3. And I just leave them like that because I can't add radicals unless they're like radicals. So those are your foci. So now again, I'm going to take the 6 order pairs here plus the center and put them onto my graph. Again, my E value, C over A, 4 root 3 over 8 reduces to root 3 over 2. Again, you won't have to calculate any E value for the quiz, but you will have to find vertices, covertices, foci, and graph it. So let's go ahead and make my axis here. And my vertices are located, I got to go to -11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 1, 2, 3, 4, 5. And then it goes up to 1, 2, 3. So I am at -11, +3 for a vertice, +5, +3. My center was also located at -3, +3. My covertices are located at -3, -1. So that's a covertice. And then also at -3, +7. So 4, 5, 6, 7. And then the focus points, again, we approximated, we can approximate this location. And we can say it's probably around -9.9, comma 3 and 3.9, comma 3. So let's go ahead and add those in. So right there. And then 1, 2, 3, 4, a little bit before 4. And again, connect your red and blue and make your oval shape. And you can see how it's longer horizontally because your major axis is horizontal. It was the bigger number was under the x squared. I'm going to post a quiz review with the solutions so you can practice. You do have the Webassign tonight for this. Tomorrow I will teach you how to write the equations of the ellipse, but it will not be on the quiz. It'll be on the test. And again, just like yesterday's notes, it was kind of short. And then we will continue on with the examples of writing the equations tomorrow. So the first 9 slides were for finding the vertices, covertices, foci, and then graphing it. And then tomorrow we'll write the equation of the ellipsis.